Hello, I'd like to talk to you about electrolysis. Now, when you examine the word electrolysis, you see two parts. You see electro, which is coming from electricity, and you see lysis. Now, lysis is the Greek word for splitting. You have seen lysis before when we looked at hydrolysis. Okay? Hydrolysis of organic compounds, hydrolysis of esters. Hydrolysis has to do with using water to break apart a molecule. Okay? So in electrolysis, what we're doing now is we're using electricity in order to break apart a molecule. Okay? So the definition for electrolysis is the use of an electric current to break down or to split apart a chemical substance. That chemical substance is usually termed an electrolyte. Okay, so some terms you're going to need to be aware of in electrolysis, apart from the definition, is an electrolyte. And an electrolyte is a compound which is a conductor, which is a liquid. So it's a liquid substance that conducts electricity. But it doesn't just conduct electricity, it also becomes broken down by that electric current, or it becomes changed by that electric current. So, what is an electrolyte? An electrolyte is an aqueous or liquid substance which conducts electricity and itself becomes changed by that electric current. Okay? So, you need to know the definition of electrolysis. You need to know what an electrolyte is. Now, separate and apart from that, you also need to be aware of how electrolysis works. Electrolysis takes place in something called an electrolytic cell. Alright? This is the key thing why I'm making this video for you guys. In an electrolytic cell, you have different parts. You have electrodes. You have a power source. You have the electrolyte. And you have the reaction vessel or the reaction container. Sometimes it's called a crucible. Now, in terms of how we illustrate this with a fairly simple, straightforward type of diagram where you have two electrodes. They're connected to, you have your electrodes, you have your power source, a battery, and then you have a container which will contain your electrolyte. Now remember, we said the electrolyte has to be either something that's aqueous or something that's liquid. Now, this is their very basic electrolytic cell. So, this is the vessel, the crucible. These are your electrodes. This is your battery. Obviously, you could get more fancy and technical with it. You put in your switch and you're connecting wires and all that type of thing. But for now, we're just trying to keep it as simple as possible. Alright? Just trying to keep it as simple as possible. So a couple things to appreciate. In your electrolytic cell, the electrode that is connected to the positive terminal of the battery becomes positively charged, and the electrode that's connected to the negative terminal of the battery is negatively charged. Okay? The positive terminal of the battery has a special name. It's called the anode, and the negative electrode is called the cathode. Alright, so each electrode has its own special name. The anode is positive because it attracts anions. So anions always move to the anode. What are anions again? Those are negative electrons, negative ions. So negatively charged ions or anions always move to the anode. And the cathode is the negatively charged electrode because cations always move to the cathode. So cations become attracted to the cathode. Cations are positively charged ions. Positively charged ions are obviously going to move to the negatively charged electrode. Okay? So in your electrolyte has to be something that is ionic. Okay? In your electrolyte, you're going to have cations and you're going to have anions. The cations are going to travel to the negative electrode or the cathode, and the anions are going to travel to the positively charged electrode or the anode. Why are the ions moving in those directions? All right? The ions move in those directions because of the attraction between opposite charges. Okay? When an ion moves to its respective electrode, it becomes discharged, meaning that it loses its charge. Okay? When ions become discharged, they form atoms. So we're going to run through a little example in a while, and hopefully that will make everything a bit clearer. All right? But one of the things that happens is that at the anode, when the negatively charged ion becomes discharged, it loses electrons. And at the cathode, when the positively charged ion gets there, it gains electrons. Losing and gaining of electrons. That sounds kind of familiar, doesn't it? Yes, oil rig oxidation and reduction. So during electrolysis, you actually have oxidation and reduction processes taking place. Imagine that.